Yeah, thanks for the introduction, Johannes. I'm Tim, and today I will actually talk about an unexpected power that I discovered with Effect. It will all be in the Lord of the Rings theme, because Effect is very powerful, but you need to know how to wield that power. So, I have been doing DevTools for a while, Node.js actually for 14 years now. And at Expand, my latest company, we're building type-safe bindings for the web. It's a dev tool, and today we will go on a journey, we'll embark on a journey. So buckle up. We'll learn a bit about Expand, just to set the context, why we're using Effect. Then I will talk about some of the unexpected challenges we face, but then also unexpected powers that we get through Effect, and make a conclusion. So I've been using Effect for about a year now. A bit about Expand. You can think of it as structured output for any website. You just define the data set, the data structure that you want, and we have web agents going out autonomously, collecting the data and putting that into one cohesive database. And so our schema library, for instance, is built on top of Effect schema, but it's a bit more like we have, for instance, models, and so it's a bit more semantic. And on the surface, this looks very simple, but actually under the hood, it's a complicated distributed system with a lot of challenges, and I will talk about that iceberg today and how we're tackling some of those challenges with Effect. So when I started last year, I was looking at what we want to build, and yeah, Node.js, TypeScript sounds like a good idea. Actually, it's the most popular choice in AI engineering right now for a good reason. TypeScript is really good at dealing with untyped JSON, and that's one of the reasons TypeScript was created in the first place. But I hit all the common issues. So actually controlling concurrency really well is quite hard without something like Effect. We have a lot of dependencies and resources we need to manage, such as browsers we need to start and stop. And so I gave Effect a try, with the intention to say, I know TypeScript, it's my language of choice. Turned out there were actually a few concepts to learn to really use Effect effectively, right? Layers, services, scopes, acquireRelease, fibers, schema, schedules. So it was actually much more to learn than I thought. And I will say that was first a bit daunting, but there are a bunch of powers that we can get through Effect, and I will talk about those powers today. And so 3 powers. First of all, magic spells, in other words, a lot of very powerful commands. We will gain mastery over time and resources. I will talk about that. And then we're gathering foresight and resilience. So let's talk about those powers that we have gained through Effect. So the new magic spells. As we have heard earlier, and all the people who use Effect know it, you now have a way to describe things about your program that you couldn't really describe before, including type errors. We can describe what our dependencies are. It's also described in the type system. I can describe the interruptibility of my program. And that's just incredible. That's not something that is part of the vocabulary for ordinary TypeScript. And resource lifecycle management is also part of these new spells that we can now cast. And to make that a bit more concrete, some of those spells, they go through this whole life cycle from we initialize the resource, we run the program, then maybe some expected thing happens, an expected error that we want to deal with, an unexpected error, in an interruption. For instance, we're deploying a new version of our service, so we want to deal with that, and then at the end, clean that up. So we have a whole life cycle that we didn't really have a vocabulary for before. And I like that analogy with the book Build from Tony Fadell. He's the designer of the iPhone, where he talks about products. You don't just look at the product itself, you look at the whole life cycle. How does the user first interact with the product or get to know the product, all the way to maybe offboarding. And if you want to build high quality, I hear a lot of high quality, and we want to build a lot of professional high quality software here, we need to think about the full life cycle of the program. And so some of the favorite spells that we use a lot, I just want to also show you some more concrete examples, are the following. Whenever I see acquireRelease in the code base, I know that some business process is usually around here. So acquireRelease, obviously I can acquire a resource, but then also release it. I can define that in one spot. I already know, okay, there's probably some business process here because we get the resources before the process starts, and then when the process is over, I release them. ForkScoped, very powerful, generally forking. Again, if I do that with promises, just fire and forget, they're gone, but I have no control. I can't just take them back or anything. Here we have extreme control. We can say I fork, meaning I run it on the side. But when this part of the program exits, please exit, like interrupt everything, fork daemon. I don't necessarily care about the scope, but when the overall project or process exits, then please interrupt, etc. Uninterruptible, we use that a lot when we are cleaning up resources. We want to make sure that that process is not interrupted. One that I recently found that I found super fascinating that I just have to show today is service option. And so I was actually asking Tyler, and I want to say thanks to the Effect team, thanks to Johannes, thanks to Tyler. Tyler's also working at Expand for teaching me Effect. Without Tyler also, we would probably not have been able to adopt all these features because the Effect standard library is so massive. And so I was asking Tyler, so I have the service that I would like to dependency inject, but I want to make it optional. I don't want that to necessarily be part of the type parameters, the requirements. And oh yeah, there's an option that I read about when I read through the code base. It's called service option. So this is just an example for me where usually the Effect team has thought about it. Like no matter when I'm asking, couldn't we do that thing? Usually there is something in the standard library, and that's just amazing to see. So in this case, we can say this is actually an internal like caching service. We cache AI requests, like requests against an AI model. Those are usually very expensive, but AI models are non-deterministic. So if you rerun them with the exact same settings, you get sometimes a different answer. And then we want to still be able to invalidate, and that's why we have this iteration service here, but we don't always want it, so that's why it's optional. And so then the next power that we really found with Effect is the mastery over time and resources. Interruptibility. Now, if you read through this code, there's nothing about interruptibility here, so why do I even put it here? We have been deploying some HTTP servers in the last weeks, and I just found this so fascinating. When I stop, like with an HTTP client, I cancel the request, I disconnect. This is automatically disconnected and interrupted by Effect. I have nothing to do here. So when I'm in the promise world, I would now need to implement a board controller. There's a lot of overhead, a lot of bespoke logic, and we are done. So in terms of interruptibility, there's nothing to do. It's always already built in, and that's just to me fascinating. Like there's no work to do. And in this case, we have, for instance, an expensive research flow that might call very expensive AI models, might cost a bunch of dollars. And when the client says, I don't need this anymore, it would be a bummer if we just waste those resources. This will, no matter where we are, let's say in the 5th iteration in the for loop, it will be correctly interrupted by the Effect runtime. And that's just out of the box there. And that's just such a superpower for us as we're working a lot with long-running processes. Scopes, obviously, extremely powerful. In this case, what is just so amazing for us is that we can define the acquire-release, like the acquisition of the resource and the release in one place. And no matter where we use it, as long as the scope closes, everything is taken care of. If we don't do that with Effect, now we have to mix the business logic with the logic of maybe we need a try-catch. Actually, we would probably need a finally. And then it's like this big mess, and now we have a clean separation. The program has nothing of that sort. And actually the release works as a finalizer. It's like a finally catcher. And so for Effect scoped here, that would actually not need to be there directly on the program. If we don't have that pipe Effect scope defined and we have a program, we will see scope is a requirement. So we even have type safety on the scopes. And last but not least, I talked about forkScoped. We use this a lot. We might have a process running that is only relevant to that program. Once the program is over, I want that to stop. No problem, forkScoped. And for instance, here we have a job that runs every 60 seconds. It's going to be cleaned up automatically, nothing for me to do. So that's extremely powerful. I don't even want to know how we would write that without Effect. So the third power, and I see I'm probably talking fast, we're 10 minutes in. The third power is foresight and resilience. So something that we are doing a lot in terms of resilience, we have model fallbacks here. This is something we wrote before the AI package by Maxwell was created. Also what we created has, I think, been influencing that a little bit. A effect is a data structure, so we can run algebraic logic over it. In this case, we're literally just using the ordinary JavaScript reduce over an array. And in this case, we have our custom retry logic by just basically having these recursive effects. But the other, in this case, let's say we first try GPT-4 Mini, and if that fails, we try GPT-4o. If GPT-4o Mini succeeds, we're not even going to go into the or else, so we're good. We don't even need to worry about that. So this is a powerful pattern. This is actual code from our code base where, and this is written by Tyler, this is actual code that we use to make sure we can fall back if a model can't do the job. In this case, GPT-4 Mini is a much cheaper model, so you might want to try that first. Another thing to say here, because everything is composable, if in the pipe we have as a first argument like a validation function that, for instance, looks at the LLM output and validates if it's valid, the with model retrying is also working, right? So the model provider failing is one thing, but the output of the LLM not being what we wanted is another thing that is quite common. And so one of our favorite patterns that I want to dive a bit more into is how we're auto-generating evals. So with AI engineering, evals are basically the equivalent to tests. What in the traditional programming world, tests are just, I have a unit test, integration test, end-to-end test. You need something like that also for AI, but the traditional tests don't really fit because sometimes it's more about, I have a string in, I have a string out. How do we actually test for that? And so evals are more testing the output of a model. But given that the quality of our product highly depends on the output of the model, we also need to put something in place. And in fact, what even the big AI labs are doing, they're playing whack-a-mole with the model. It's a black box. And whoever plays whack-a-mole quicker is usually more successful in deploying AI. But besides some exceptions, most people can't look into the model, so we have to basically poke holes in such a black box as quickly as we can. And so that's why evaluation tooling is very important. And in AI apps, usually you should start with that to even establish what is the model capable of. In our case, this is a very rough architecture diagram of what we're doing. We have an agent that controls a browser that interacts with a website, and then the data that we get out of the browser, we're passing that into an AI model. So in our architecture, yes, we need to get the data from the website, but after that, almost all the quality of our product comes from how good the model is. And so that is something we have to test. And so we obviously want to especially test the cases when the model doesn't do what it's supposed to do. And so something that we have developed and that we're using internally that might also be helpful for all of you, we haven't built that as a library yet, but we might, is automated eval generation. And so what that means is we are wrapping one of these AI functions. For instance, in this case, we're just summarizing. And so let's say we want that summary to be less than 100 words. And if the LLM has given us more than 100 words, it's not in the snippet, but just imagine that, then we could fail. And now in that failure case, because we have tab error, we're actually generating code. And so the analogy for that is a bit like with JSON stringify. The JavaScript runtime is recursively going through the JSON tree, checks out if there's a toJSON method available, and if yes, it calls it. We have the same structure for, we call it toCode. So if you think about it, we have a function call. So what do we want to actually put into like an eval file? So we're creating a file here. We would want some imports. We might need to run some code before that. And then we have the actual function call with the inputs in there. And so those are the three things that we came up with. So each input, each data structure in our system, and by the way, this data structure that you're seeing here with the expand AST is based on effect schema, because effect schema is already serializable. It makes those things much easier. It basically defines what imports it needs, etc. in the code. So it tells us how it wants to be printed as code. And so as long as we define that recursively for all the input data that we put into a function, we can now wrap this function, and if it fails, we can take those inputs, serialize all of them with the toCode, recursively call toCode, and now this is a very simplified version down there. We print the imports, the code, and then the function call. In actuality, we have a little bit of vtest and effect vtest around that, but that's the idea. So, and this is actually in our case generated to a separate folder. We call it, I think, generated evals. It's not checked into Git, it's Git ignored. And each of these evals now gets a hash. And what I can do, and we print that to the terminal, yeah, we have this new eval. I can say pnpm accept that hash. It's copied over into a folder that is actually checked in with Git. It's now in CI, and now we have just auto-generated a test case for the AI. And how you exactly want to check those things depends. Some people use something called LLM as a judge, where you ask the LLM, is this a good response by the following requirements? So there are different ways to have these evals defined. But this helps us because if you have such a long process, especially for agents, multiple steps, and let's say each step has a success probability of 90%, and it's a 10-step process already, you're almost failing all of the time, every single time. So you want to make sure that each step is as reliable as possible. So that's how we simplify the creation of that. There are a lot of tools for evals in AI. One of the best ones is Brain Trust. It's just this like GitOps workflow, and being able to automatically generate those evals is not always as easy. So that's how we are making use of Effect for that. So already getting to the conclusion, I think I've been talking way too fast. Anyway, more time. So the ring effect. What is the conclusion here from my side? So we definitely face challenges. It's not yet perfect, but it's so incredibly powerful. Stack traces still have potential. I use the JS debugger a lot, and in the JS debugger, the stack traces are gone. But at least using effect fn, which is really incredible, we use it all over the place now, improves that a lot. At least for me, was quite a learning cliff, because I realized, and that is also the next point, if you don't really buy into all the effect paradigms, especially layers and dependency injection, it can be painful to be in this in-between state where you use it a bit but not fully. And I think that's also the point around incremental, that being incrementally adoptable. It is, but I would get out of that phase of having a part of the code base in effect and part not as quickly as possible, because having everything effect just makes it so much nicer. On the reward side, obviously, we get insane power, functional programming with imperative syntax. So I have learned FP, but haven't used it in production, and so this makes it very approachable for us. The concurrency patterns are just insane. We have full control, including interruptibility. And then for us, websites are all over the place. Sometimes they're online, sometimes not. They're changing. And so we really need fine-grained error handling. I don't want to have nested try-catches that have different cases with that. That's just where effect shines. And we're really happy to have effect there. And in terms of fine-grained error handling, we decide also what is the error that we expose to the user. It's very easy to do with effect HTTP, and what's our internal error that might have way more details. So those are things that you now have. It's making it very easy to design those concerns. And so coming back to the original idea of I didn't really want to learn something new just to build it quickly, I actually learned a new language. In fact, rather an embedded language. It's a bit like with React. React has a whole new syntax. It has different concepts and is basically a different runtime. Effect basically brings all of these. You could say the syntax is just TypeScript, but it looks quite different. So I would say it is probably, you can call it an embedded language. Now, there's still a big advantage over actual different languages, which is I have direct access to the full TypeScript ecosystem, Node.js ecosystem, and I can just call all of those libraries. So that's obviously the big advantage. So we get all the powerful new paradigms while we're fully embedded with the rest of the ecosystem, and that's the big power for us. So is it worth it? We have been using it for a year. So we still use non-effect for like very basic scripts, especially now with AI coding. Sometimes that is easier for the AI to generate, but anything that we put in production, we definitely use effect. And I hope next year if I give a talk that we also say simple scripts are also in effect now. But anything that is in prod, yes. And I haven't even put any slide here regarding OpenTelemetry, but OpenTelemetry is just a game changer. And I don't want to deploy anything without OpenTelemetry anymore. If there's something breaking, we can just have a look at it, and it's really incredible for us. So for the people who are new in effect, it might seem daunting because you have maybe 10, 20, 30 concepts that you have to learn before you can really make use of it. I would say the community is amazing, and I have learned so much from all the people. People respond very quickly in Discord, so you're not alone. It's an amazing fellowship. So, last but not least, thank you, and we're hiring. Thank you.